Welcome. This is the SAT practice test number 7, section 3, math test, no calculator, one page at a time with hints and tricks. So please pause this video now and attempt these 3 problems if you haven't already done so. If you would like to do them without hearing any hints first, I'll go through and provide some brief hints for each of them and then go through each of them in more detail. So for 13, to get you started, you will want to use either long division or synthetic division for this one. You cannot try to just cancel out the x's in the numerator and denominator. Those are in separate terms. So a lot of people are tricked here and they want to just start to cancel because they see the x in the numerator and denominator. You will need to use long division or synthetic division, which I'll talk more about when we go through it. For number 14, the hint would be to translate, to really take your time and read this. Again, word problems, situation problems, read them 2 or 3 times. Once to get a basic idea, twice the second time to go through and highlight key terms and information, and then last time to make sure you are answering what's being asked. So just to start with some basics, we have the keyword of sum, and we're going to pay attention to perimeter and height cannot exceed 130 inches, and the perimeter is determined by using the width and the length. Box has a height of 60 inches, and the length is 2.5 times. So again, you want to reread that, but just to highlight some key information. And for number 15, for this one, we really want to acknowledge that these 2 expressions are going to be equal. When it says it can be rewritten, in other words, that is going to be equal. So we could set those 2 expressions equal to each other. Another hint for this one would be to go ahead and multiply these 2 factors in the parentheses. You could use FOIL for that. Okay, so go ahead and go back through these to give them a try if you haven't already done so, and I will work them out in more detail. Okay, so for 13, again, long division or synthetic division for this one. We have a quadratic trinomial divided by a linear binomial. So if I write this out for long division, you might remember this from your Algebra 2 days. We have x squared minus 2x minus 5. So briefly, to perform division of polynomials, you're concentrating on the first term in both the divisor and dividend. If this is unfamiliar to you, you might want to look for some videos that provide more detail. But basically, I'm thinking, how many times can x go into x squared, right? Or what might be easier is to say, what do I have to multiply x by to get to x squared? And that would be x, right? So then you go ahead and multiply. If you think of your long division, you're going to go ahead and multiply x by x to get x squared, and then x by -3 to get -3x. And then what do you do next in long division? You subtract. So x squared minus x squared is 0. -2x minus -3x, we're really adding there. Be careful, that's going to give you a positive x. And then we can drop down the next term of -5. And then back to the top. If I'm taking x minus 5 divided by x minus 3, I'm dividing x into x, or what do I multiply x by to get x? It would be a +1. So +1's going to go up there, and then I go ahead and multiply. X times 1 is x times -3 is -3, and then I go ahead and subtract. Again, this is a long process, so you might want to look for other videos if this is not familiar. X minus x is 0, and -5 minus -3 is -2. So I have a remainder of -2. I want to write that as -2 over x minus 3, which looks like answer choice D. Okay. Real quick though, those of you that are familiar with the synthetic division, and again, this is something you might want to go research a little bit more if it's not familiar to you. So for synthetic division, all you have to do is take your coefficients of the numerator. So we would have 1 for 1x squared, we would have -2 for the -2x, and we would have -5 for the constant of -5. And then you take what you're dividing by, the x minus 3, but you change the sign of your constant. So -3 be considered a -3, so we're going to have a +3 here. And again, this is synthetic. This is a shortcut to long division. So I start with dropping down my first coefficient. And this mimics long division. It's just a faster way to do it. So I drop that down to get +1. And then it's multiply, add, multiply, add. Again, going through the process of how we were multiplying with my arrows up here at the top. But because it is the opposite, we're actually going to add instead of subtract. So I'm going to go ahead and multiply. 3 times 1 is 3. And then I add to the next coefficient. -2 plus 3 is 1. And then I multiply again. 3 times 1 is 3. And then I add again. -5 plus 3 is -2. And this gives you the coefficients of your answer, of your quotient from dividing. So because you were dividing by x, your power is reduced by 1. So we were dividing into x squared, so that means our quotient will have a degree of 1 or exponent of 1. So this would translate to 1x to the power of 1 plus, so you have a +1. And then the last number is your remainder. So remainder of -2, but you put that over the divisor of the x minus 3, which you can see in that solution. So that one was a lot, something that you might need to go back and spend some more time on. For number 14, though, this one is kind of just nice translating. There is a lot of information, but if you take your time, it's really not that bad. So if we go through the restrictions for the boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box. So sum we know is add. Look for a video of translating keywords for your 4 basic operations: add, subtract, multiply, and divide. I'll link that in the description. So we know we're adding the perimeter and the height. So I'm going to go ahead and make myself some more room. Perimeter plus the height cannot exceed, so it has to be less than or equal to 130 inches. The perimeter of the base is determined using the width and the length of the box. So if I just concentrate on perimeter, right? So the perimeter is going to be based on the width and the length. So I would have 2 widths plus 2 lengths to get all 4 sides. And the box has a height of 60. So I can go ahead and go back to my original inequality. I'm just going to make myself a note that the height is 60. And the length is 2.5 times the width. So if the length is 2.5 times the width, I'm just going to substitute that in, 2.5 times the width. So I really have 2 times 2.5 widths to represent the 2L. Okay, so if I simplify this, the perimeter is going to be 2 widths plus 5 widths, gives me 7 widths. And which inequality shows the allowable width in inches of the box? So now I have to go back to my original equation, not equation, inequality rather. And I'm going to substitute in my 7W for the perimeter. So let's just highlight that in yellow. So I'm taking my 7W and putting it in for the perimeter. So I'll have 7W plus 60 for the height is going to be less than or equal to 130. And then if I just solve that inequality, it's going to tell me for the width, which is what I am looking for. So if we subtract 60 from both sides, we will get 70 over here, and that divides nicely. W, the width has to be less than or equal to 10 inches. So which one is an acceptable range? We would have A, between 0 and 10. So again, some basic substitution, but the key is translating first. All right, next one, number 15. Again, key is that that can be rewritten, so we know we can write those as being equal to each other. So I'm going to take the 1/3 x squared minus 2 and set it equal to the 1/3 x minus k times x plus k. We know k is a positive constant and we are solving for it. So if I clean up the right side, I'm going to go ahead and FOIL those two binomials. So that will give me x squared plus k minus k squared times the original 1/3. On the left side, there's nothing I can do there yet, so I'm just going to leave that alone. Plus k minus k, that's nice. That makes it a little easier to deal with. So we have 1/3 and then x squared minus k squared. If I go ahead and distribute that 1/3 on the right side, that gives me 1/3 x squared minus 1/3 k squared. And now I can move some things around, or I might just automatically look at this and say, hey, I have 1/3 x squared on both sides. Those are going to cancel each other out, right? If you subtract 1/3 x squared from both sides, which is what allows us to solve for k, right? Because now we only have one variable, one unknown. So if I take my -2 equals -1/3 k squared, I'm going to divide by -1/3. If I'm trying to solve for k, I want k by itself. So that gives me +6 equals k squared. And now it's very easy to solve for k. If I take the square root, it would be plus minus the square root of 6, but it tells us that it is positive. So we are only going to use the positive root, square root of 6, which is choice D for that one. Okay, so those are problems 13, 14, and 15 of the SAT Practice Test 7, Section 3. Please look for the next page, problems that are grid in. So you provide your own answers for numbers 16, 17, and 18.